Hello, everyone. So please enjoy the beautiful Anna, and she's going to explain everybody what's and how test legacy code, which we all love and hate at the same time. Anna, just before we start, a couple of questions, if you may. Can you first explain who's your target audience, or for whom you prepare the talk?
Yeah, so the presentation is mostly for developers, regardless of the language, and who have some legacy code that they need to maintain. Or maybe they've just arrived on a new project and it's a legacy code.
So it's more mainly for developers, and if I'm not mistaken, you will be talking on unit and acceptance testing.
Yeah, right.
Okay.
Yeah.
Excellent. And also, I think it'll be nice to just elaborate a little bit on what do you think legacy is, because for everybody it might be something different.
Yeah, so it has a different definition for most people. So normally, I've seen it described by someone where legacy is code that doesn't have tests, which means that basically everything that doesn't have tests is legacy. So it's kind of self-referencing. But yeah, for me, legacy, it's either code that is very old. So there were some maybe historical decisions that were made that no longer hold true today, or maybe we had to take some shortcuts, in the beginning of the project. But also, legacy code can be fairly recent, because I've seen code that has been delivered like a month ago, and you look at it and it's legacy. So because it's either poorly designed, or like designed in a way that makes it not very maintainable and not very testable. Yeah,
Okay.
that's how I see legacy.
So basically, you'll be helping people with how to test unmaintainable and poorly designed code. Okay, so let's start then.
Yeah, let's begin. Hello and welcome to my talk. This is a picture that I took about 10 years ago at a race. And I've never seen a NASCAR race before. And I never realized that adding duct tape to a car is actually a normal part of the process. And it's a bit how I like to see legacy, where you can't really stop, midway and then pack up, go back to the workshop and just try to reconsider how you're going to do things. You have to keep going no matter what. The business is continuing. So for the purpose of this talk, I will assume that you all have at least written some unit tests in the past, and you have at least a rudimentary knowledge of design patterns and perhaps even some clean code principles. As for the programming language, I will show some examples using PHP, but not very often, and they're quite simple that even if you use a different programming language at work, you'll still be able to follow along. So it's not a code heavy presentation. So most people end up not writing tests because when they arrive into a new application, what they notice is that they need tests to refactor, because that's what we were told. We need tests in order to be able to refactor, but we also cannot write any tests because we first need to refactor the code to make it testable. So we have like this catch-22. So people end up just not writing any tests for the existing code, with the hope that one day they'll have the opportunity to completely rewrite the code, and then it will be testable. It will be new shiny code, and they'll be able to write tests for that. And so it's not really a problem, though, because that problem only exists when we write the wrong kinds of tests at the wrong time during the refactoring process. There's different levels of tests that you can write, and you have to write them at the right moment in order for them to make sense. So I'll try to explain what most people get wrong when tackling legacy testing and some simple solutions to that problem. So quickly about myself, my name is Anna Filina. I've been coding since '97. I started with VB4, but I also work with PHP, Java, Ruby, C Sharp, and a whole lot of other languages. Um, I'm a legacy archaeologist, which is a fancy way of saying that I dig into really old code bases to try and unearth what is happening in there. I also love test automation. I do a lot of public speaking. I mentor developers, to teach them these topics. I tweet about legacy and other stuff. So if you'd like, there's a pinned thread in my profile that you can read and enjoy and nod your head in agreement. And I also have a few YouTube videos that you can watch with some advice for programmers. So you see, legacy and testing are the two subjects that I'm most passionate about, and I kind of built my career around that. So let's talk about tests. Imagine a situation where you come into a legacy project and there are no tests at all. It would be a whole lot of work to get from zero to full testing coverage. And so people what often are tempted to do is to go on a testing spree. So like they stop every other type of work, like no more fixing bugs, no more, or especially no more writing new features, and they just dedicate the next month, for example, for writing tests, or even just a week. But the problem with that is if you just write tests and the code is not very testable, what happens is people often just run out of steam because it's tedious, it can be boring, it's a lot of effort, and it's also very hard to justify dedicating so much time for something that it's kind of hard to show the value. I mean, yes, we can educate people all we want, but the managers or clients, they want to see something a bit more tangible. And so what I like to do, and what I recommend that people do, is always write tests while doing other work. So for example, if somebody reports a bug, instead of going in and doing the fix manually, we can create an automated test right away. So when we try to reproduce a bug manually, we might go into the database, put the database in the right state for it to be able to go through the line of code that is currently a problem. Let's say it's a null pointer exception and you want to put a breakpoint there. So you want to make sure that the execution reaches that location. So that requires a lot of understanding how the code works and what sort of variables you need to set and what to put in the database to get to that state. And so instead of doing it manually and then basically throwing that effort away, we can write a test for it, an automated test. Of course, it will require a bit of a foundation. So you have to invest a tiny bit of time, at least setting up some foundation, maybe getting a CI up and running so that you can run those tests automatically next time. But do go and write that test. It's not going to be longer than investigating an issue manually. And the cool thing is with the tests, you don't have to manually go to the database and then reset some records. The test will sort of reset the database into the right state for you, which is great. And so you can just put the breakpoint and keep re-executing the test to collect enough information and test your various fixes. The other way you can add new tests is whenever you're writing a new feature. So if you need to add completely new classes to the application or just new behavior, just write a test for that behavior, and you'll be able to add that to your test suite. If you plan to refactor a piece of code or maybe change some existing behavior, any kind of change basically that you plan to do to the application, you should have a test for that. And so over time, what will happen is you will build adequate coverage for your application. So not everything at once, but every time you touch the code, you can make it better and you can add automated tests for that. But then once you finally get around to writing those tests, you realize that the tests are not actually unit testable. So the code was not designed to be unit testable. It's not always the case, but with legacy, almost always, at least in my experience. There's tight coupling all over the place. Things rely on the framework too much. There's static calls all over the place. So the code was not designed to be unit testable. Therefore, your unit becomes kind of bigger than what you hope for. So let's say you want to test, you're like in the context of an MVC framework and you want to test a controller. Well, you kind of have to pull in the entire framework. You have to bootstrap it because you need like the configuration, you need the database access, you need a whole bunch of things. And so doing that, bootstrapping the framework, hitting the database, that is very costly for the purpose of testing something that you would have liked to test using a smaller unit, like maybe a class or a method. But then you end up having a much heavier test, which is obviously harder to maintain. And so you wouldn't want to create as many of those tests, because then if the tests take a long time to run on the CI, maybe an hour, maybe even overnight, then people will just stop writing new tests and stop running the CI. And so all of these efforts will gradually decline. So what you want is to go in the right direction so that you can also keep the momentum going. So you don't want to run out of steam. You don't want to make that mistake. So in addition to those, your application might call external APIs. And so if you are unable to separate, the logic that's being executed from the API call, then your CI will now need to access the API. Like if you test things, let's say it's a web application, you test things in the browser, you can call the sandbox API. That's not a big problem. But in CI, you don't want to necessarily start doing that, because maybe you have rate limiting, maybe the API is not always up or doesn't respond in a timely fashion. And that means that your CI will start to randomly fail. So again, if your CI is flaky, people are going to start relying on that. It's not going to give you the confidence that you want. And then also some areas of the application might require extensive mocking. And this is something I noticed with, for example, ORMs or query builders and any other sort of fluent interfaces, where what people sometimes, when they try to, like, they are able to isolate that from the framework, great, but then it still depends on this library, like on the API of the library that you're using. And so the mocks, like you could have pages and pages of mocking, basically saying, well, when I say creates query builder, it returns an object of that type, and then the call to from is going to return this, with these arguments is going to return that. So you do all of that mocking, and in the end, really what you're asserting is that all of these methods of this library that you don't really care about has been called in the right order, and that somehow proves some sort of behavior, which is not interesting. And then, of course, if you decide to change the ORM, all of those tests become invalidated. And at the end, you still don't know whether you're getting what you want out of this method where you see the query builder. Because what you really want is either the string, SQL query at the end, or even better, checking that the database has returned the correct records. But that's an integration test. So you're kind of stuck with not being able to go down to the correct sort of lower level of tests. And sometimes you just cannot mock. Things are just not mockable. You have final classes all over the place, or maybe they're just static calls, so they're not even mockable. But that doesn't mean that the code that you have is untestable. It simply means that it's not allowing you to write unit tests. And if you do try to write sort of unit tests, well, they end up being convoluted and not useful. Basically, what you end up writing are integration tests. So the natural reaction when people encounter code that's not unit testable is to try and refactor it to make it more testable. So let's say you take up an application that has these classes, and then you try to refactor things to something else. But the act of refactoring, what it does is can potentially change the existing behavior. So obviously you need tests, right? Before you even refactor. But even if your code was unit testable in the beginning, the problem with unit tests is that they are sensitive to the structure of the code. So like the class, the signature of the method, what it returns, all of that. So say you write a test for a class in your legacy application, and then you refactor that. But this class might not even exist after refactoring, which means that the test that you wrote doesn't fit. I mean, it cannot be executed at all, which means that you have to throw that unit test away and write a new one. But then what was the purpose of writing the first unit test? I mean, maybe you've gained some knowledge, great. But the unit test, you basically write it and immediately throw it away. So it's a bit of a waste. So the act of refactoring is pretty much invalidating your unit tests. And if you're dealing with a legacy application that would require more significant refactoring, that means that you're more likely to lose your unit tests in the process. And so even if you don't completely remove, the class, you still can have changes that can break your test. So if you take a big class and you figure out that there are maybe too many responsibilities in it. So you want to split those responsibilities, so you break it up. Maybe you extract the method, and I don't mean like a private method inside the same class, because that doesn't actually change the structure, because you always test through the public methods. But maybe you extracted that particular behavior into a dependency. Maybe you change the method signature because the original one, because you're dealing with legacy, right? So maybe you decide, well, this is a great class, but I need to maybe reduce some of the number of reduce the number of arguments to a shorter list. And so, or maybe you convert the primitive to a value object. And so now you have to change the method signature, which will invalidate your unit test. Or maybe you just reorganize your dependencies. So that would make your unit tests obsolete, which means that you need to write new tests. But if you're both changing the code and changing the tests, you don't actually have, that kind of defies the purpose of regression testing. So with regressions, what you want is you have a test, and you want to be able to keep the same test as you change your code. So what's the solution? Should we be more conservative in our refactoring? But then our hands will be tied, because what we want, with the refactoring is to create the most optimal design, right? Because we do want to have the opportunity to refactor. We don't want to just, add tests and keep the same technical debts, within the structure of the code. So really the solution is not to be more conservative, but the solution is to not write the unit tests right away. And so some people will go crazy when I say that. But hear me out. The idea is you can start by writing acceptance tests. All right. So instead of interacting with individual parts, you can interact with the whole system. So let's say if you're writing a web application, you might want to send an HTTP request and then check the output, so the response. And so the cool thing about this kind of test is that it doesn't care about the internal structure, because it tests it as a whole through something that is not going to change, because you're not necessarily going to change the HTTP request. What you're trying to change is the structure of your code, not the behavior. If you're changing the behavior, obviously the test has to change. But here we're not talking about changing the behavior. We want to preserve the behavior as we're playing with the code. And so not only does it not care about the internal structure of the code, but it doesn't even care in which language it's written or which framework it uses. So I use this approach to progressively rewrite an application from ASP Classic. And so ASP Classic At the time I was doing this this project, ASP Classic was already dead for 10 years, right? And so what I did is I replaced that with PHP. That's what the client wanted. And the acceptance tests were sitting at a level so high, basically interacting through the HTTP protocol, that it didn't care that we swapped the language completely, as long as it can respond with the same thing, right? We maintained the sessions in the same way, the database was still there. So nothing really was affected by that. So these kinds of tests can survive refactoring. And that's the beauty of it. So you can create a sufficient safety net to avoid behavioral regressions, and then start playing with the structure. So here's an example for those who are not familiar with acceptance tests. Let's say, I personally like to use any framework that supports Gherkin. So here, for example, a user can subscribe with a credit card. That's the scenario. So given I selected a subscription level, like how did I do it? Did I click this and that? The details of that are in the definition of that step in the code. But this is something that is readable for a business person and anyone else who would like to audit this test. And so when I enter valid credit card details, again, what is considered valid is entirely up to you. And you can also have, invalid, and then that will create a different behavior. So then I should see a payment receipt. So this is like a pretty simple test that you can write. And it can interact with your, application. In the case of the HTTP request, you basically send, in the given, you send, make sure to put the software in the right state. When is the request, and then is the response. And so you compare those. And so here are some examples of frameworks that you can use that I personally used in the past. So for PHP web application, I like to use Behat. For C#, I've used SpecFlow, and that's both for web and CLI. I coached a Java dev recently to write tests for a CLI application, and we use Cucumber for that. There are also some frameworks, that I haven't personally used, but there are frameworks for mobile and desktop applications. So it doesn't actually matter whether it's CLI or web or whatever the way to serve your application. If it's running and if there's a framework for it that supports Gherkin, you'll be able to test it. Now, these tests are slower because they interact with the system as a whole. But the thing is, you don't need to write as many of them as unit tests. And they're different from some sort of lower level tests that are, as slow, which also interact with the database and the framework, but they're still sensitive to the structure of the code. Because if you rename the classes, if you move things around, they might still break. So you have acceptance tests, but you'll still have unit tests to cover the more fine-grained logic. So the idea is not to have a sort of line coverage with acceptance tests, but rather try to cover some of the scenarios, at the very least cover the happy paths and a few sort of alternative or exception paths, but do at least cover the happy paths. And then the rest, you can, as you refactor, then you'll be able to write some unit tests. But yeah, what you want is to start with something that will survive the refactoring process. So how do unit tests really fit into this picture? So let's go back to the acceptance tests. We have written them in order to avoid regressions in the behavior when we start moving the code around. So the same test will pass both for the original and the refactor code. So now we get into the refactor code, and as we write the new code, we write new tests, right? So we've created a new class, or we're changing a method signature, and that particular class is unit testable. Let's go. Let's start unit testing it, and that is how you also build your unit test coverage over time as you refactor. So here's an example of a an application. This is an MVC application. It's a product controller. What it does, it gets some products from the database and then renders it to the screen using a view file. So the problem with this is you cannot instantiate this class without bootstrapping the entire framework. And the reason for that is because the method disrender actually comes from the abstract controller, so the parent of the product controller class. And so that means that we need to bootstrap the whole framework. Additionally, we're touching the file system, right? Because we have like a path to a view file. So this is definitely not going to be a unit test. Yeah, and so some people, they might say, okay, well, it's an abstract controller. Can I not mock the disrender method? Well, you can't really, because if you want to write proper unit tests, you should not do what I call partial mocks. So you don't want to mock some of the methods, either protected or even public methods that exist in the same class that you're testing. And just because product controller and abstract controller are two different classes, the abstract controller does not exist by itself. And therefore, any code that's inside it should be considered as part of the execution path of whatever is in the product controller. So we should not test this render, or we should not mock this render in this context. So we have to separate them, to create a proper dependency. So really, I just need to find a way to get rid of that parent, and then and inject something to be able to render as a dependency instead of relying on the parent. And then I would need to bootstrap the entire controller, and then I can mock things, and I can have a proper unit test for the product controller class. So what I can do is, instead of extending, I inject that templating component. Okay, and the templating component has the render method. So here, so __ construct is the way we write constructors in PHP. So we inject the templating component through the constructor. And now that it's a proper dependency, we can go ahead and mock the call to the render method. So in our unit test, we instantiate product controller. And when we do instantiate, when we use the new keyword, we pass to it, instead of the actual templating component, we just pass a mock of the templating component. And then we can mock the render method from there. And so by doing that, we have just made our controller class independent of the framework with proper dependency injection. And that means that we can start, writing a whole bunch of tests for every execution path in the search method, because there could be some conditions and multiple execution paths. And now we can write a whole bunch of tests for that. So just to recap about writing tests during refactoring, start by writing high-level tests that will survive the refactoring. So the exact level is up to you. Like people like to, not everybody likes acceptance tests, but write something that's high enough level that even if you refactor everything, even if you swap out the framework, or you upgrade to a new framework that might be incompatible, you want your tests to be able to survive that, so that you have more freedom in the kind of changes you can do with your legacy application. So something that kind of makes sense in your testing pyramid that you'll be able to maintain in the future, because you don't want those tests to serve just for the refactoring. You want them to exist in the future as well. Some people, they promote Selenium and stuff like that. I don't personally like that. I just find them very difficult to maintain. So I almost never write those. I just find Gherkin to be a lot more natural, but it's really up to you. So, and then the unit tests should be written for any new or refactored code. Or if you have code that is hopefully already unit testable, then you can add unit tests to those classes. But yeah, don't try to make unit tests work for code that is not unit testable. It's just not going to work. Yeah, and so writing new tests is relatively straightforward. So we arrive into a legacy application and we have two levels of tests, one that we can write upfront and others that we can write only when our code is unit testable. But what happens if you arrive into the project and it already has some tests? How do you decide, how to deal with those tests? Sometimes, the tests are there and they're great and you can leverage them. That means you have no problem at all. But very often, the application would have tests, but they were written such a long time ago, and often don't really work anymore, or just very hard to maintain. Like they can be such bad tests that you can't really salvage them. And when you start changing your code, those tests start to break. So that they might be sensitive to the structure of the code. And so I had this legacy project once where there was like a tiny feature, like a really, really tiny feature, and it had 300 acceptance tests. Not for the whole application, just one feature. And it certainly didn't feel like that feature needed 300 tests. Like I couldn't see where they managed to dig up so many scenarios. And so, the head of the department, of course, told us to keep the tests, but they were written 2 years ago and nobody ran them since. And so they didn't compile. It didn't compile because the way the company split up their code is they had different repositories, and so they had some common libraries that were used across the various departments. And so the API of those libraries changed, and so that code would not compile. So we're not even talking about, so the code specifically for the tests did not compile. Okay, so we went in and we fixed the problems. We made it compatible with the new libraries. And then we tried to run them again, but now they failed due to database changes because, again, those tests were touching the database. All right, so we spent several days fixing just a couple of tests to see how much time it takes. And after those fixes, many tests still kept failing for all sorts of reasons, right? And so we didn't really see an end to it. We weren't quite sure how long it was going to take to get everything fixed. So instead of going in and trying to fix everything, we just decided to review the tests and try to fix maybe one of them and sort of extrapolate. And so we reviewed them, and what we found out is that most of the tests were wrong. So not sure why they were even in there. Or a lot of the tests were redundant. So that's how they came up with 300 tests. There were a lot of redundancies. So some of the tests actually failed for weird reasons or even passed for the wrong reasons. So for example, there would be tests that check that something did not happen. So for example, this test would pass if an email was not sent. Okay, but that means that this test could pass if something other, if there was another reason for the email to not be sent other than the behavior that was specified. Like there would be a bug, and that will result in the test passing. So like we had to reverse that and check specifically for what we wanted, not that something did not happen. The other problem that we had in those tests is that they were comparing basically large database dump after the execution. And so when the test would fail, it would be extremely difficult to figure out why the test has failed. So it was pretty much useless because if you can't figure out why it failed and you put your breakpoints and you spend like a whole day trying to figure it out, it's not very useful. And there were also many unnecessary permutations. And when I say permutations, like let's say you have a scenario with 2 database records and 3 database records and 4. And then in reverse order, just for the sake of it. But that did not change the behavior that we were testing. We were always asserting the same behavior at the end. So why try all of these unnecessary permutation? Like it would go through the exact same execution paths in the end. It would just loop more times, but didn't actually make any difference. So basically what it would seem is that the devs just tossed in as many tests as they could, in the hopes of making it seem like they were very thorough. So there was no strategy really behind that. And even worse, despite having 300 tests with so much overlap, there were many scenarios that we found that didn't even have any tests. Like there were problems in the code and there was no test to actually catch that problem. So basically, we figured out that the whole test suite was worthless. It's not always the case, but it happens. It happens quite often in my experience, that you come into a legacy application and just has tests that are pretty much impossible to salvage. And so the dilemma is now people are afraid to throw code away in general. And it's even harder to convince management that, all of this has to be thrown away. So what we did is to convince people to throw them away. We estimated the effort for, how long would it take to fix the existing tests versus rewriting them from scratch. So we estimated that, after fixing a couple of tests, we estimated that everything would take 6 months, which was ridiculous. And even then, even if we do fix them, they're still horrible, horrible tests. They would be unmaintainable. So why would we even bother, putting in so much effort just to end up with not really good tests? And there were still tests that would, there were still scenarios that would require new tests. So we'd still miss a few and would need to invest that effort. So in the end, my team threw away the tests, and in just a couple of, I think just over in a little over a week, we wrote 46 new tests, 46 new tests for the scenarios that we had. So that we basically eliminated all of the redundant tests. No need to sort of repeat the same scenarios with slightly different tests just for fun. Slightly different data just for fun. And the tests were quite easier to read. So everything was covered, no redundancy, easy to read and maintain. So just to give you an idea of how difficult it was to maintain the tests that were in place, and something you have to be ready for. This is what I mean. Like there's way too many columns. You can have you need to scroll sometimes 5, 6, 7 screens to the right in order to see all of the columns. And they would also have a whole bunch of rows. So that would make any sense. Basically, it's a data dump or a database dump as the as the input, and a database dump as an output, which is not very useful when you're trying to debug a particularly difficult scenario, and you're trying to understand, which, you have to check the foreign keys and everything, and kind of try to model that in your head, like try to get a mental model of this, to try and find out which columns of which rows actually contribute to the failure, or to contribute even to the behavior that you're trying to test. Like there's no way to know. And you can't really audit this. So this was for the tests that I had were for a banking application, and they need to be able to audit the business rules. And you cannot audit something that nobody understands. And you can certainly not sign it off and saying, yep, that works, as this is exactly what I expect of it. So as I said, it took us one full day for 2 developers just to audit one test, just to try and figure out what's happening. And so what you can do is transform that. So this is like a slightly different example, right? Because I cannot show the code from that other application. But let's say we have this weather application and we import weather data. And so we import weather data for various cities. And if we attempt to import data that for a city that does not exist, then we should see a warning instead. So like it's undefined city. So let's say that we have already defined Moscow in our system. We don't care where it's defined again. Those are implementation details, but just to understand how acceptance tests work in Gherkin. And so now we import a file that contains 2 entries, one for the city that exists and another one for the city that does not exist. So the second one is Montreal, Canada. And so we then execute the daily weather import script, and we check the output. And the output, well, the behavior that we're observing is that what weather entry would have been imported. And for the other one, we would add a warning to the log saying we cannot import this data because this is for a city that is not in our system. So we have no idea what to do with it. And so the behavior is, either we import what we have, or should we completely stop and delete the previous entries when there's one error? How do we deal with it? Or do we keep importing, and then when we find an error, we stop there and maybe we have like a resume script? So there are a lot of possibilities of what the observable behavior is, and that's what you need to determine and put in your test. And so something like this is a lot easier to understand than whatever the heck we had before. And we only needed 46 tests like this instead of 300, something that's really unreadable. So, this is much easier to maintain. And so the lesson here is when you encounter existing tests in the legacy, you have to ask yourself, will these tests survive refactoring? So similar to when you write new tests, will they survive refactoring? So if you have decent unit tests already in place, if you see that they're well isolated, you can keep them. That's fine. But yeah, do take a look at the tests. Are they going to survive refactoring? Also, you have to evaluate the effort of fixing the tests versus rewriting them. I mean, sometimes you just need to tweak things a little bit. Maybe they're really good tests, but other times you have absolutely nothing worth salvaging even, and the effort to try to salvage it is just not worth it. And then also ask yourself the question, do these tests give you the confidence that the application behaves in the way that you expect? Because sometimes they do the opposite, the exact opposite. Instead of giving you confidence that things work, they make you doubt everything. So like if you have, like I explained the tests with, the email not being sent. So if you have a bug in your application and that causes the test to pass, now the question is, okay, well, obviously the test is not very good, but the question is, does the application actually work as expected? What exactly is expected? So you have all of these more questions than answers, right? So if you don't have the confidence in those tests, it's better to get rid of them. And also look at those tests, and even if you can fix them, think about how you're going to maintain them. Are you actually able to maintain them? If it's completely unreadable, unauditable, are you comfortable having the responsibility to maintain them? Because now you have to make sure that every single detail of that gigantic test is exactly the same as you refactor the application. So if you can read the test, you can realistically modify it to have the correct expectations. So if the behavior needs to change, you're going to have to edit so many of these records from the database dump that, you'd have no idea what's happening in there. So once you ask yourself all of these questions, the solution will usually be quite obvious. And that is all I have for you for today. Are there any questions?
Okay, thank you for the talk. That was quite interesting, I think, not only to me. And now question section. So let's start with probably the simplest one, which is curiosity about checking that something didn't happen. Do this kind of tests should never be written?
Right. So it's a bit broad. I've seen quite a few, a little bit of follow up on that in chat. So it depends. If there is more than one way to arrive at the result, and some of those ways are perhaps bugs, then that's probably a dangerous assertion, which means that we can have a failing application perhaps even crashing, but still have a passing test. So I would invite you to really think about what is it, how do you qualify sort of the correct behavior. So let's say if in addition to having 0 errors in the log, let's say it's an HTTP application, a web application, then you would want to have an HTTP status code of 200 to also make sure that there was no underlying bug, that there was no 500, which maybe caused the logger to crash, which I've seen very often. The loggers rarely get unit tested, so the logger maybe have crashed and so did not write any errors into the log. And so if you verify just the fact that you have 0 errors, that test will pass. But in reality, you still have a crash. So it's important to maybe pair that with something else that will ensure that something didn't go amiss at the same time. So if it's a CLI script, you check for the exit code, and for the HTTP application, you check for the HTTP status code. And also make sure that when you write web applications that you use the HTTP codes correctly, so that you send a 500 in case of a crash and not a 200 and just wrap the error like in a JSON or something.
Okay, so for the next one, if I get the question correctly, so for the external API, so what can we do if external API is the system which only presents in real world, or you can't probably mock it, and it has complicated setup, expensive, and so why test it?
Yeah, well, I think I partially answered that, because when I was describing all the pain points, basically these are the reasons why you can't really test certain things. Now you might want to still test bootstrapping the framework and the database access and other things when you write acceptance or like any other high level tests. For the external APIs, what I personally like to do is to use something called wiremock. There are also equivalents elsewhere. So wiremock is something that's written with Java, and you can have, let's say you have a Docker environment in which you run your application. You can actually have a wiremock listening on that particular URL for the API, and it can intercept them and have stubs to return, canned responses. And that's very useful, because then you can have like the full cycle tested, with the integration, with the API. How will I respond to this kind of error from the API? How will the application react? You don't necessarily want to have to test all of that manually only. And because it's a stub, you don't go to the outside world, so your CI is still self-contained, and it makes things very, very fast as well, because you don't have to wait on the other system. And I actually implemented something like that when I did one of my clients. I did payment with Sberbank actually, and we integrated with their API and then used wiremock in order to have that in the tests.
Okay. Next one. Thing is that again, as from my experience as well, what if acceptance tests are slow? So what if it needs literally hours to execute?
Yeah, well, I mean, that is more a question of optimization and how many of them you're writing. I think this question will be more suitable for the Zoom call later on, where I can try to dig maybe a little deeper into specific concerns and try to address them. But yeah, I mean, no test which should run for hours.
Mhm. Okay, and probably the sweetest question to my decision, at least I think so. It's like how actually how do you make sure the acceptance tests you write cover all the use cases? Are they based on requirements? Because for legacy systems, sometimes requirements are not
Very
reachable,
clear. Yeah.
or you just reverse engineer the code. So how you think that you test everything?
Uh, that actually can be a whole talk in itself, but I'll try to make it short, and maybe we can chat some more on Zoom. But I mean, in general, I try to have a testing strategy where I sort of separate what part am I going to cover with unit tests, ideally every line of code. So I try to have some sort of line coverage. And on the other side, I have the acceptance test. And there I, as you said it so well, I will cover use cases. Now, those use cases, if the system is properly designed, it becomes obvious, but in legacy it's different. But if it's properly designed and you have like this onion architecture, at the application level, let's say you use an MVC framework and you have these controllers, and in there you have several scenarios that are not necessarily unit test scenarios. So you would say, for example, a use case would be, if I fill in a form and I submit and everything is valid, that is one scenario. If I have a validation error, that's another scenario, because we need to figure out how does the system respond when the form is incorrect. But now it doesn't matter whether you have this error or that error or 5 errors or just one. That is something that you leave for the unit test. So the specifics are for the unit tests. So you have a lot more of them and they run really fast and they try to isolate things. But then you join everything together in the acceptance test. And that's where you'll have those, positive and negative scenarios, like all sorts of alternative scenarios. Usually they're quite clear if you design what they're called, a use case diagram. Basically, you can create a use case diagram. I find that particularly useful, or sometimes even flowcharts. But you don't go like into all the ifs of the code. You really think about how the user interacts. The user doesn't need to care about certain things. So from the user's perspective, if they're filling in a form, either they got it right or they didn't get it right. So they only see two possible scenarios, really, unless one of the scenarios is, very specific and has a completely different behavior from, let's say, displaying the errors at the top of the form. If the behaviors consistently display any errors in the form, that's just one scenario that you need to test.
Okay, that's probably a good question for the discussion zone, because to me it also not always clear, because if you join the legacy code or legacy project, it basically means that it's rare. Most of the time it's large system and you probably have no clue what the system is capable of and what you need to test. And if there is no tests, no documentation, no people who really can help you with all these scenarios, it's something which brings a lot of pain for developer to at least understand that all the scenarios are covered.
Yeah. Well,
So
and
if you have
you can
something
never
for that,
really, like, if you don't have somebody to show it to you, or you haven't read every single line of code, it's very hard to guarantee that you have caught all the scenarios. But at the very least, what you can do is, whenever, as I said, whenever you make any changes, try and find the different scenarios. So if somebody says, well, we want a new business rule where, if this particular, given this particular state, this is what I'd like to see. Like, there's this exception that I want to be able to add, like this new rule. Well, in order to test that rule, first you need to figure out what's the happy path, right? That is something that you can figure out pretty quickly. And then from there, you just continue. And as you work with the code to implement this new feature, this new business rule, you will eventually discover the various scenarios that are hidden in there. I don't think that you can go like on a spree and just be 100% sure that you found all the cases, because scenarios are not as obvious as line coverage in unit tests. So yeah, it is not always
Yeah,
straightforward.
I do agree. So I think that our time is over. So we need to join Zoom room to answer probably live questions from others. Thank you so much for your time and for your talk.
Thank you. Have a good day.
See you in the room.